Hello everyone. So today we will learn a very important topic of our machine learning journey, that is called feature scaling. So before we go into the hands-on coding using scikit-learn or a PyTorch, the, the overall machine learning coding practices, so आज let's discuss about why we need the feature scaling. To understand that, I took a small data set that is called housing data set, and which has basically the two features. One is area and second one is number of rooms, and third one the target variable is price. So अगर आप देखोगे what happened in the normal situations, in a practical situations, तो अगर area value increase होता है, obviously price will be increased. Number of room increased होता है, then price also increased. So that means that okay, area and the price and number of room and the price both having basically a linear relationship, right? So what we can write? So then we can safely go to a formula that is called y is equal to mx plus c, a straight line formula. So अगर यही स्ट्रेट लाइन फॉर्मूला हम लोग दो वेरिएबल के साथ अगर कर रहे हैं, हाउ विल डू इट इज इक्वल टू y इज इक्वल टू m1x1 प्लस m2x2 प्लस c, राइट? नाउ c को हम लोग थोड़ा बाहर रखते हैं यहाँ पे बिकॉज c इज अ कांस्टेंट. अगर हम लोग इमेजिन करते हैं दैट ओके m1 is near about m2, okay, because m1 and m2 is basically the coefficient. So that means what will happen for the very first one? If we take a very first row, I can write y is equal to m1 into 1000 plus m2 into 2 plus c, right? So that means when this training happens, suppose model training happening, right? Model learns what? Okay, this particular value is a very huge value, right, compared to this. So model will learn that okay, give weightage to this particular value. That means give weightage to area. Because if any changes happen here, suppose the change of area 1000 to 1200, so that means compared to this value, and suppose some changes happen to m2 to m4, suppose m2 I mean 2 to 4, so that means the change is here, the impact of the change for this particular first one, if we suppose 100 to 100 200, will be very huge. So that means the model will give weightage to area. And same thing happens when we do the predictions. The model will obviously introduce a lot of bias because it will always sensitive to area. So this is basically the problem. How we solve this problem? We try to standardize the features, because if you see, the problem is basically both x1 and x2 belongs from a different range of variables, right? X1 like 1000, 1500, 1800, and x2 is 2, 3, 4, 16, like that. Okay, so this is basically the problem. And to solve this problem, the technique to solve this problem is called the feature scaling. Now there is ways to do feature scaling. The major ways are basically we call it normalizations. Another way is called standardization. Okay, normalization scale. Normalization is basically if you have a feature like x1, it's like x1. So x1 ko we will put it into 0 to 1 ranges. Okay, same goes on with x2. x2 also 0 to 1 ranges. So यहाँ पे तो x1 the values will be 0 to 1 and x2 also 0 to 1. Okay, how we do it? Simple formula, very simple formula. X normal is equal to x minus x min by x max minus x min, and let's put the brackets. So now let's make it one variable, right? One particular thing. Let's put it into 1500, this row, particular this row, and this row if we do the normalization, okay, what will happen? First x1 will be, so x1 normal, it will be 1500 minus x mean is what? If you see these three variable, 1000, right? Now, what is the x max? Three values. What is the max values? 1800, right? Right. This is basically 1000 in x mean. That means 500 by 800. That is equal to 5 by 3. Correct. 5 by 3. Now, x to normalize. If we put again x minus x mean. X means how much? It's 3, right? What is the minimum value? Right here. And is the maximum value? Oh, sorry, this is 5 by 8. What is the maximum value? 4, right? And what is the minimum value? Again 2. So that means it is 1 by 2, right? Now, if I introduce the same equations here, so now same equation if I put, now what will happen? M1 into 5 by 8 plus M2 into 1 by 2, right? Plus C. Now if you see, so now when model learns, if there is no bigger values, right? 5 by 8 and 1 by 2 are more or less same. I mean, it's way better than 1002, right? So that means model will not get anything that, okay, it would give weightage to a particular features. Right? So this is the way we solve the problem. Now, let's discuss some of the problems of normalization technique. So there are two problems. One problem, the major problem, is called suppose the outliers. What is the outlier? Suppose this currently x2 has 2, 3, 4, three values, right? So now a human mistake happened, a new value has been put, is 18 or 16. Okay, so 16 is basically outlier. But if you put the 16, what will happen to the standardized value or the normalized value? So now if you use this particular formula, now x max is now 16 and x mean is till 2. So now denominator is very high, which result every value will have a very small, it will convert to a very small value, right? It will still be in the 0 to 1 ranges, but the values will be very small. So for a particular outlier, every value got impacted. So this is one of the problem of normalization. Now when we use normalization, majorly normalization is used when you are not sure that, okay, what is the distribution of the data, or you know that, okay, the distribution doesn't follow a Gaussian distribution, or you are using a machine learning or deep learning algorithm that doesn't assume that, okay, your data is a Gaussian distribution, right? Many algorithm actually does, like you can say your gradient descent. Gradient descent always works very well that if your data is in Gaussian distribution. So that gradient descent we don't do basically the normalizations, right? Whether if suppose some different deep learning techniques or some kind of suppose I remember, yeah, if you use this k-nearest neighbor, so that time the normalization basically helps very much. Okay. Now from next classes we will learn, okay, how to implement it in a scikit-learn or in a coding environment. So that is basically very easy. Before that, we would need to talk about another technique that is called a standardization, but not in this video. I'm ending this video here only, and please do share. If you like the video, please do share, like and subscribe my channel. And surely from the next very soon, I will create another video on the standardizations. And in case if you have any doubt, feel free to comment it and I will surely answer you.